Okay, today I'm going to give you some ELC review problems to help you with your packet. Today, for now, this video is for numbers 8 through 15, because we have already done numbers 1 through 7. For number 8, what is the smallest of 3 consecutive positive integers? It's good to highlight or underline your keywords. We have 3 consecutive positive integers. If the product of the smaller, so you have to remember what product means, of the smaller 2 integers is 5 less than 5 times the larger integer. So we have 3 consecutive integers. Consecutive integers are 3 numbers in a row. So if I were to ask you what comes after 1, you would tell me 2, because 2 is the next number. So what we would have to do, because we don't know what the integers are, is we would have to use a variable. So we can use x. So if our first integer is x, and I tell you to go from one integer to the next, I'm going to ask you, how would you get from 1 to 2? And you would have to add 1, so your second integer would be x plus 1. And you want to name your third integer in terms of x also, because you want the same variable. So if I were to ask you, how would you get from 1 to 3, you would have to add 2. So your third integer is x plus 2. So that's just to show you a visual of how you get from one integer to the next. So now we don't need the 1, 2, or 3. That was just to show you how to get your variables, expressions. So now we set it up based on what we see. 3 consecutive positive integers. The product of the smaller, this represents your smaller, 2 integers, so we're going to have these 2. These are both going to represent your smaller 2. So the product of the smaller 2 means x times x plus 1, because we know product means to multiply, is means equals 5 less than, well, because we have less than, whatever we see first goes last, so it's 5 less than 5 times the largest integer, and this is your largest. So now you have your setup. So after you set your problem up, it's just a matter of multiplication and solving. So x times x is x to the second. X times 1 is 1x. We have distributive property. And then we have this is equal to 5 times x plus, don't forget to do 5 times 2. And then you bring down your minus 5. Since that's not in parentheses, you don't need to distribute this 5 to that. Now combine any like terms that you have, and since you have quadratic and you want to solve it, you have to set everything equal to 0. So we're going to move everything from the right side of the equation to the left side, okay? You always want to try to keep x squared positive. That makes your problem a lot easier. So we have x squared plus 1x is equal to 5x. These are like terms, neither one of them has a variable, plus 5. And then we're going to move everything from this side of the equation to the other side. So we need balance. So if we subtract on one side, we have to subtract on the other side. So now we have x squared minus 4x is equal to 5. Subtract your 5 so that you can have everything equal to 0. Now since you can only combine like terms, we have x squared minus 4x minus 5 right next to each other, because this has a variable and this does not. So you just make them horizontal. And now you get to use your factoring rules. So we have to factor this, and remember how you can use your x? You multiply the first times the last, which is negative 5. I'm going to put a little dot here for multiplication. And always bring down your middle term, which is negative 4. Sometimes people call that splitting the beads. Now what can you multiply to get negative 5 that you can add to get negative 4? And we know that 1 times 5 is 5, and 5 minus 1 is 4. But we want negative 4, so that means that your negative has to go to your highest number. So now this is how you're going to use this for your factoring. So we have x plus 1 times x minus 5 is equal to 0. Notice we want positive integers. So when we solve for x, remember how you can have either the first factor equal to 0 or the second factor equal to 0. The only solution that's gonna work is the positive solution. So when we subtract 1 and we get x is equal to -1, that's not gonna work because that is a negative number. But when we add 5 and we see x is equal to 5, that's gonna be our smallest number. They wanna know the smallest, so you're done. Make sure that you bubble it in correctly. You have to put your 5 up here and then go to 5 and bubble it in. This is called a gridded response question. Make sure that you look for what they're asking you, because if they ask us for the second smallest, we would say x plus 1, so we'd have to do 5 plus 1. So just remember to look for what they're asking. Okay, now, make sure you understand this. If you need to go back, you may. We're going to move on to number 9. The function f of t is equal to -5t squared plus 20t plus 60 models the approximate height of an object t seconds after it is launched. How many seconds does it take the object to hit the ground? So if you look at number 9, when something hits the ground, it's at level 0. So what you're going to do is you're going to set your expression equal to 0 and do the exact same thing you just did. You're going to factor and then solve. So this is going to equal 0 because that's when it hits the ground. So we have -5t squared plus 20t plus 60 equals 0. That's that. We can just flip it around because of the symmetric property. So now we have to factor out our greatest common factor. The highest number that we're going to 5, 20, and 60 evenly. So we can take out a -5. And then you have to say, what can I multiply by -5 to get this back? A good way to figure that out is to divide each term by -5, and that lets you know what you need to put in parentheses. If we have 3 terms here, we should have 3 terms here. A negative divided by a negative is a positive, which is wonderful because you want t squared to be positive. 20 divided by -5 is -4, and 60 divided by -5 is -12. So now, when you factor it, you can use your x. You don't worry about the -5 for now. First times last means that's -12, because there's a 1 here that we don't see. Bring down your middle term. Now ask yourself, what can you multiply to get 12 that you can subtract to get 4? 2 times 6 is 12, but if you say 6 minus 2, you get 4. But which one has to be negative? Now the highest number has to take the negative sign in order for this number to become negative. So now you have your factors. So we have t, you put your -5 here. -5 times the expression t plus 2 times the expression t minus 6 is equal to 0. So notice you're just bringing down your -5. We want to know how many seconds it takes for the object to hit the ground. So we're going to solve for t. If we said, let me show you all the pieces. We could say -5 is equal to 0 because that's one factor, but we know that's not true. So that's wrong. We could say t plus 2 is equal to 0 because if we have a 0 here, when we multiply, we get 0. So we would have to solve, and we get a negative solution. But you can't have negative time, so that's wrong. So let's use the third factor and see how that works out. And we get t is equal to 6, so our answer has to be 6 seconds. So it takes 6 seconds before the object hits the ground, so you put your 6, you bubble in your 6, and you're done with number 9. So let's move on to number 10. Okay, number 10, 2 times Antonio's age plus 3 times Sarah's age equals 34. Sarah's age is also 5 times Antonio's age. How old is Sarah? So everything looks like it's in terms of Antonio's age. So we're going to use a variable for Antonio. So we can say Antonio's age is equal to A. But here we see 2 times Antonio's age plus 3 times Sarah's age is equal to 34. So we know that's an equal sign. Sarah is 5 times Antonio's age. So Sarah is 5 times Antonio's age. We want to know how old Sarah is. 2 times Antonio's age, I'm using this right here, 2 times Antonio's age, 2 times A, plus 3 times, so you're going to do 3 times Sarah's age, but her age is 5A, and you can just write it like this, is equal to 34. And now you just solve your problem. So we have 2A plus 15A is equal to 34. Combine your like terms. 17A is equal to 34. Since you have multiplication, you use the inverse operation of division to solve for A. And we see that Antonio is 2. But we want to know how old Sarah is. So think about what you need to do. Okay, you take your 2, you go back and you plug it in, and so Sarah is 10. So you go over here to your gridded response, put your 10, bubble in your 1, and bubble in your 0. So that was pretty good. That wasn't a bad problem. So let's move on to number 11. For number 11, we have the function f of x is equal to 2 times 2 to the x was replaced with f of x plus k, resulting in the function that you see in the graph below. What is the value of k? So you have to understand how graphs shift in order to understand this. Well, we have this right here is of the format f of x equals a times b to the x. Well, A is your y-intercept, so that lets you know where this piece started. So we're going to write y-intercept, and that's A. So the y-intercept was 2. This function got shifted down here, so what we have to do to find out what happened with K, because that represents your shift up or down, is figure out how we get from here to here. So we bounce. 1, 2, 3, 4, 5. We went down 5, so that's a negative 5. So the value of K is negative 5. So you bubble in your negative, and you bubble in your 5. And that's it. If you want it to shift left or right, I just want to show you how that looks. Instead of having a large K right here, you would have a lowercase, a K right here with a variable. So, if you have something like that, I have something I want to write down for you so that you could write it down. Okay. So what I'm going to do is summarize. Okay, if K is positive, you shift it up. If K is negative, you shift it down. That's what we did here. We started here because we figured out our y-intercept was 2, so the graph was up here, and then it was shifted down. So if your K is lowercase, if your K is small, so if we have K up here, it's the opposite. If it's positive, instead of going in the positive direction, you would actually go left. Okay, so it would be a shift left. And then if you have f of x is equal to 2 times 2 to the x minus k, you go right. So if you have a large K, you're going up or down. If you have a small K with the exponent, you're going left or right. This one's very logical because it goes up when it's positive and down when it's negative. This one's exactly the opposite of what you would think. The negative actually goes in the right direction and the positive goes in the left direction. So write it down, please, so you can study it. And then we'll move on to number 12. Suppose that the function f of x is equal to 2x plus 12 represents the cost to rent X movies a month from an internet movie club. Michaela now has $10. How many more dollars does Michaela need to rent 7 movies next month? So the way you can approach this, you can actually approach it pretty logically. She wants, so the cost is equal to 2 times 7 movies plus 12. So that's going to be 14 plus 12, which looks like $26. How much does she have? $10. So what you would do is you would do 26 minus 10. So she needs 16 more dollars. So your answer is 16. Bubble it in. And this is what right here, she has $10. So she needs 16 more. Make sure you're okay with that. And we'll move on to number 13. So basically what I did was I substituted. In case you missed that, I did 7 movies times 2 plus 12. Number 13. The larger leg of a right triangle, so we're going to draw a right triangle. We know that. You should draw a diagram if they give you a visual that you can see in your mind. The larger leg of a right triangle is 3 centimeters longer than its smaller leg. So they're talking about it in terms of the smaller leg, so let's use a variable for the smaller leg. And this is 3 longer, so you're going to add 3. You can put 3 plus x or x plus 3. The hypotenuse is 6 centimeters longer than the smaller leg. So the smaller leg is x, so we're going to do 6 longer than x. How many centimeters long is the smaller leg? Addition is commutative, so once again, this order doesn't matter. When you're using subtraction, you do have to be more careful. So now let's put our expressions where they go. Your hypotenuse is always across from your right angle. That's how you know where x plus 6 should be. Your smaller leg is your short leg, so that's your x. And your longer leg is the longer leg. The drawings often are not drawn to scale, okay, just so you know. So now what they want to know is how many centimeters long is the smaller leg? What theorem can we use here to find out what we need to find out? Pythagorean theorem, good. So we're going to use the first leg squared, or one leg squared, doesn't matter which one you choose, plus your other leg squared is equal to your hypotenuse squared. That's important that your hypotenuse is what you set it equal to. So now you get to practice your tic-tac-toe if you'd like to. X plus 3 squared just means x plus 3 times x plus 3. Remember that? So then you can multiply x plus 3 squared. Let's color code. Let's use a different color. So x times x is first. That's x squared. X times 3, 3x. Do the same thing with the 3. 3 times x is 3x. 3 times 3 is 9. So everything in blue is what you combine. These are usually your like terms. So here we have x squared. 3 plus 3 is 6. So plus 6x plus 9. And then we're going to bring down our plus x squared equals, you can do another tic-tac-toe board here. If it's positive, remember, all you have to do is put the 6. You don't have to put plus 6. Squared means twice, so x plus 6 times x plus 6. And then you do the same thing. You multiply x times both of those numbers and then 6 times both of those. So you have x to the second, x times 6 is 6x, 6 times x is 6x, and 6 times 6 is 36. Once again, you have your like terms here. So now we have x squared plus 12x plus 36. So now we combine like terms. We have a quadratic because we have a power of 2, so we have a parabola. So it's going to look like a U when we graph it. But we want to move everything to the left side of the equation or to the, so the x squared is positive. So first, let's combine our like terms. We have x squared here and we have x squared here. 1 plus 1 makes that 2x squared. And we bring down our 6x and our 9 because there's nothing else over here like that. Now we're going to bring down our second expression and move everything from this side to the left. Remember, to do that you have to use inverse operations or inverse signs if you want to think about it like that. This is a positive x squared because there's no sign in front of it, so you have to subtract it because you want it to go away. And that makes it go to 0, which is what you want. So that's gone. You have to move your 12x. You can do it all in one step. That's gone because that goes to 0. And you have to move your 36. And we're going to combine that. So that's gone from this side. Now you combine. So we have, this gives you practice with your polynomial addition and subtraction. 2 minus 1 is 1, so you can just put x squared. 6 minus 12 is negative 6. And 9 minus 36 is negative 27. And now it's equal to 0. So you get to factor. You get to use your x. Multiply first times last is negative 27. And then you bring down your middle. Don't forget your negative. Now what can we multiply to get 27? Whenever this is negative, you subtract to get it. So what can we multiply to get 27 that we can subtract to get 6? 9 and 3, good. Because 9 times 3 is 27, but 9 minus 3 is 6. What's negative, your 3 or your 9? Your 9, good. Because the highest number has to take the negative sign so that the sum will come out negative. So now we're going to factor, these are your factors. X plus 3 times x minus 9 is equal to 0. We're looking for a side, so we're going to go ahead and solve for x. We can have x plus 3 equal to 0, because 0 times that will give you 0, or x minus 9 is equal to 0. It's a little messy now, so I'm going to erase a little so you can see what's going on. Okay, now what you're going to do is you're going to subtract 3 from both sides. Could that be your answer? No, because you can't have a negative length. If you have a negative length, you don't have length. Good. So what you're going to do now is solve where you have x minus 9. And that's your answer. So it says, let's see, how many centimeters long is a smaller leg? So that's, since x represents your smaller leg, your answer is 9. And don't forget to use your gridded response. Once you get your answer, don't forget to put it in the gridded response. That's very important. Okay, we're going to do 14 and 15. Number 14, Katie and Jennifer are playing a game. Katie and Jennifer each started with 100 points. So I think I decided to make a table. I thought that was the easiest way. At the end of each term, Katie's points doubled. At the end of each term, Jennifer's points increased by 200. So you have Katie, and you have Jennifer. They each started with 100, so this is actually pretty fun. So the way I did it, I had, and the way I did my turns, I went ahead and put turns over here. So for turn number 1, they both had 100. Then you go to turn number 2. At the end of each turn, Katie's points double. So if you double 100, you get 200. What do you get if you double 200? 400, good. What do you get if you double 400? And then, let's go ahead and do Jennifer's for now, and then we'll continue with Katie. So Jennifer, at the end of each turn, hers increased by 200. So what does increase mean? To add. So you have to add 200. 100 plus 200 is 300. And then 300 plus 200 is 500. 500 plus 200 is 700. And the question is, at the start of which term will Katie first have more points than Jennifer? So let's look at Katie and let's look at Jennifer. Oh, we're finished, because here we are. This is when Katie has more points than Jennifer. So at the start of turn number 4. So your answer is 4. Because Katie has 800 here and Jennifer has 700. Now the last problem we're going to do in this section, this is all calculator inactive, so you cannot use a calculator on anything that we just did, which is perfectly fine because you can do all of this without a calculator. Okay, let's move to number 15. Alex walked 1 mile in 15 minutes. Sally walked 3,520 yards in 24 minutes. In miles per hour, how much faster did Sally walk than Alex? So you're going to have to make a conversion. So the first thing I did was I said, okay, well, 1,760 yards. How many miles might that be? Right, well, that's 1 mile, but I decided, how many times would that go in there? And I thought 2. So if I were thinking like you, I think what you may do is you might say, let me check it out. You can divide, but it's just as easy. I think it's easier to multiply. So 2 times 6 is 12. 2 times 7 is 14, plus 1 is 15. 2 times 1 is 2, plus 1 is 3. So we see it's just 2 right here. When Sally walks 3,520 yards, that's equivalent to 2 miles. So she walks 2 miles in 24 minutes. And she walks 1 mile in 15 minutes. So we say 1 mile, so we're going to put miles over minutes. Okay, so first let's do Alex. Alex is here. Alex walks 1 mile in 15 minutes. So we're going to set up a proportion. 1 mile is to 15 minutes. That's how many miles is to 60 minutes. And why do you think I chose 60 minutes? Because 1 hour is 60 minutes, and they want to know their answer in miles per hour. Good. So now 15 are going to 60 4 times, and 4 times 1 is 4. So right here, x is equal to 4. What I really did was I cross-multiplied and I divided, which is just 15 times x is equal to 60, and then you go through and you divide each side by 15. Okay, we know 15 twice is 30, so if we double that, we know it's going to take 4 times. So we have 4 for Alex. Now let's look at Sally. Sally walks 2 miles every 24 minutes. So we say 2 is to 24 as x is to 60. I reduced 24, and that was 1 over 12. That made it a lot easier for me. So 1 is to 12 as x is to 60, because 2 are going to itself once and 2 are going to 24 12 times. How many times does 12 go into 60? We know 5 times 12 is 60. So 12 goes into 60 5 times, and 5 times 1 is 5. So here we're going to have 5 for our answer. If you need to see the work, let's cross multiplication again. 12x is equal to 60. And then you just divide both sides by 12. 12 1 is 65 times. So Sally, we have 5 for Sally. We have 4 for Alex. And what we want to know is how much faster did Sally walk than Alex. So think about what you would do if you're comparing how much faster. You want a difference. Difference means subtract. So we're going to do 5 minus 4. So it's going to be 1 mile per hour. Put your 1 here. And bubble it in. And you're done.